Going to wait to see if it's streaming. Going to study recursion today. Because I wanna become better at recursion. Just clarify in my mind how it works. So it's easy to understand, and also to help me understand if I made any mistakes here, or if the way that I'm thinking about it makes sense or not. So yeah, I didn't do much on this since yesterday. Or 2 days before. I'm gonna put 1.5 hours the timer. And I made another project here, simple project that emulates what I did on the other one. But I ran this and it took a massive time and it didn't complete, so I think I'm gonna decrease the timer here. And what I wanna do is do the same thing that I did with the script visualization here again. I think it's gonna be easier now because I have more experience and I understand things better. And this one is the current one. So what I'm gonna do is go back to the project that I had on the visualization stuff and then remember what I did there. It was stuff related to the stack frame and tracing the stack frame, and then I'm gonna see what objects I can take and maybe redo the script that I did there, and then I'm gonna put this stuff on there and try to create a graph of the execution of recursions, and then try to understand more how it works. Like the main thing that I want to understand is how the variables change in the recursion, and the whole thing about when it reaches the base case and it goes back, what happens with these global variables here. That's the main concern that I have, because in the way that I'm doing on the other one, I rely on them being the same as they were before they reach the base case. I'm not really sure what happens. I think I explained on the previous one, so I'm not gonna explain now. I'm just gonna build this thing. So I think here I'm just gonna run. So what I did here was pretty much the same, not the same, but a very similar thing that I have on the other script, which creates the tree with the decisions. And the only thing that I have left now on this one, I made the pods, update the pods. I didn't test this yet. And I'm a little anxious to test this because like there might be a mistake, and then it's gonna take me, it might take me a bunch of time to figure out what's wrong, because there's a bunch of stuff. Like I didn't run this as I was building, so. And I didn't run because I couldn't, I had to do everything I think before I start running and debugging, and now it's gonna be the part. I still haven't finished all the decisions, but it's gonna be really easy to finish the decisions. It's just think about the actions that can happen after each decision here. And this is about the poker tool that I'm building. I think the last part was 18 or something like that, and that's where I'm at now. So when I study recursion to understand how this is gonna work better, because if there's a problem with this, it's gonna be easier if I understand how it works. Like if I have a more confidence on the way that I think it should be working, the way that I'm thinking about it. So yeah, I think I'm gonna put some music here. And then I'm gonna just run this stuff here, and then I'll think about it. So here what I did was create this mock global variables, let's say, with a bunch of values. And here I have to use global so that it understands that is these values here, otherwise I was getting a mistake. And then I put the options, like I try to emulate as similar as possible, but making it as simple as possible, so it's easier to understand. And also I thought about, and the only thing that is going to be different if I don't have the memory to build the whole tree, is I'm just gonna remove the parts that I add the nodes, but the rest is gonna have to be the same, I think, because the essence of the thing is just constructing all the possible lines, like the essence of the algorithm. If you remove all the other parts, like there's no way that I can remove the calculation for the pot, because that is connected with the bet sizes, and yeah, the rest has to be pretty much everything the same. The only thing that changes is adding the nodes to the other tree. But I don't see how it wouldn't work. unless I make a mistake on the recursion. That's the only possible way, I think. And I should have the memory. If that is not the case, I should have the memory. So if I ran out of memory, I think that the first thing that is gonna go through my mind is that I made some mistake on the recursion, and there's an infinite loop somewhere. And this is the part that's gonna be challenging to debug if that happens. So that's why I want to study this. So here, if there's an F, then it's a base case, then it hits there. If there's a count, this is simulating the effective stack. So every time I loop here, I increase the count so that it hits the base case. And if I don't put this, then it gets into the limits of the stack depth. So I think that's a good indication if there's an infinite loop where it just reaches the maximum stack depth. So then here I check for the streets, and I loop over the actions that I have as the global variables there, depending on whether it's a string or not, which is very similar to what I'm doing on the other script, the other project. Then I call the function recursively with the parameters. And then on the river, there's also the base case when there's a string. And then I'm just looping here, so let's run. But the issue with this is that it might take a longest time to finish running. So while this runs, I'm gonna go open this one and remember what I did here. And I'm also gonna read I think I'm gonna try to use ChatGPT and read the Python documentation, just see what kind of information I can get from the stack trace. Because that's how I did the other one. And there's been a long time since I haven't looked into this one, so I don't remember really well. But I remember there was several different methods of visualization that Vivax that helped me do it. And each one of these folders contains a different method, I think. I think the lib visualizer allows to see the connections between the imports. And then the script visualizer allows you to put some code. And the way that I was doing is just using the stack trace, and then I put to trace in some limits, and then I run whatever code I want to run there. And then as it runs the code, I did another function that captures the information that I want to capture from the code and put it on a CSV. And then from the CSV, I create the graphs. But what I think I can do differently is just create the graph right away. I don't need to create a CSV. But I didn't do that at the time because I think it's more complicated, so it should be interesting to figure out. And this is just for the site part. I just did the site because to put on the portfolio, and because I was thinking about maybe later on making it available to people. Maybe I will do that at some point as well. But I wanted to add some extra functionality if I was gonna make a site out of this, because and also I wanna see if I can find another way to create these visualizations that doesn't involve Network X, it involves maybe another library, because I don't like them that much the way that Network X is, like for the stuff that I'm trying to do. If I could find a way or think about a way maybe to display on the browser the execution, I think it would help a lot to not only debug, but to also understand every single library, because it's a lot better to visualize the whole network of the things that are being called and passed around that you can't really see just by looking at the script. But I think the issue here is that I modify this library, the PyVis. I need to remember where is the file that has that translates the code. Maybe it's not on this project. Yeah, the templates hold the graphs. And I was also trying to do this stuff with the languages, like getting the documentation. That's another idea that I think someone should do it, but it's kind of hard to do. But there probably is someone with a lot more experience than me that could build this probably and make money out of this. And I think would be like, I would be willing to pay, I think, a subscription for this, which would be like create an algorithm that creates a graph of all the syntax of all the possible languages, and then shows you the relationship between the syntax of all the languages, because that way you can like significantly increase the speed that you learn every single language. So pretty much create something that shows the common stuff between the languages and what is different between them, and highlights them in the graph. That would be very efficient to learn, I think. But it's very hard to do. And this stuff is just for the Pivis. Maybe I erased the thing that I created, the graphs. Oh, the annoying thing was the neighbors as well. I remember I copied that. Because you can call some function from the graph that allows you to change the color based on the amount of neighbors that the node has. That's very useful to see how, and to increase the size, just see on the graph. But I think I might have deleted the part that I did, or I not deleted, but I lost. The part that I was creating the data frame. That's what I'm trying to find here. Oh no, maybe it's this thing here. This one, I think I remember. Yeah, I think is one of these files here. That I was looking at the documentation and trying to convert some information from that I get. Because the way that it's passed is weird. Yeah, I was trying to make the distinction between global and local variables, I think. Like seeing what I can get from them, and then I got this function somewhere, I think from Stack Overflow or something like that. This is kind of the tricky part about doing this, because I don't understand really well, like, what's in memory, how the execution is, what are all the things that are being used, and how the execution is gonna work. What I want to look at is just the stacks, I think. I want to see each stack in the same way that the videos do the visualizations. Because I want to know what kind of information is on each stack until it reaches the base case, and then how the information changes when it starts tracing back. And then I want to develop an approach, like a meta approach to the way that I think about the recursion. Because I think that's the main challenge. In the other problems that I have, like, I think the main pattern that I got so far, and that I use all the time, the way that I think about solving the problems is usually using a loop and then doing something inside of the loop. So there's both the loop, the if-else statement, and then encapsulation of functions. So usually that's the main three things that I use to solve everything. And the way that I think automatically about the problems is by thinking about these things. But then recursion fucks me up because you have to think about the end of the problem, let's say, first. So first you have to think about the base case, and then you have to understand this movement of how it's gonna go. It's especially difficult if there is other stuff that happens after the recursion, which is the case that I have now. Because then you have to keep track of all of the things that are going to be happening between executions of different parts of the function. That's the part that gets really confusing. So I want to develop an approach in the same way that I have for the loop, where you can visualize in your mind like the logic of how it's gonna go when you're trying to think about how to solve the problem. And then this is the function, I think. So the challenge is knowing what kind of things are the most important to keep track of, to make the visualization like be useful, I think. So obviously this shoe here would be useful. But then I need to get the variables as well. Oh, this finished. So it was a lot faster because of the counts. So what I want to do, I think, is print here. The question is, where do I print? Because the thing is, if I print, I don't want to see necessarily the base case, I want to see when it goes back. That's the thing. So I think every time that it calls itself recursively, at that point it branches off, and that is the point that creates the tree structure. Because every time it calls itself recursively, it branches off through different paths, maybe. Yeah, because then when it continues the execution from that point, then based on the control flow is going to determine the structure of the tree. So the control flow determines the path of the nodes, and the recursive calls create the branches, I think, for each node. So I want to capture, I think, when it calls here, the recursive. But then what kind of stuff do I print? So that is, maybe I just print one thing at a time and then I see. I think I print other cache first. So the way that I'm thinking now is that every time that it calls itself recursively, like the recursive call is like a node on the tree. So when it calls itself recursively, then it's going to branch off into two different paths, because the paths that it creates are the control flow of the function. And the control flow determines like how the tree is going to evolve, I think. And then once it goes back, I want to catch the point where it goes back in the execution for the last place that it branched off. So I think that's on the recursive. And what I want to understand is how the global variables change from that point to the base case, and how they're gonna go, what's gonna happen when they go through the other path. But I want to find a way to not only see that, like, I think it's better to print now, but then what I want to do eventually is to use the stack trace and the visualization thing to create the graph that allows me to visually see and to reason about how the flow of how the information is changing based on the flow of the recursions. Like the main goal is to try to get an intuitive understanding of how how the information is connected with the recursion. So I think local is the local namespace, and then the global namespace. And this has the variables, but there's also something that's called vars, I think, yeah. But I don't understand really well, so I think I'm gonna ask these kinds of things to ChatGPT, see if I can get any clarity. Because I remember, like, some of this stuff I didn't really understand really well, the difference between them, last time that I did this. The difference between free vars and vars, for example. I think the main thing is understanding how the namespace changes and how different variables at different position changes. There's the structure of the information, which is everything that is happening on the function and everything that is happening on the memory of the function. And then there's the flow of the execution, which is the sequence that the thing follows, which is based on the functions. So the functions are just labels, and then the labels determine like where it's gonna go, and that creates the data structure, I think. So the data structure is the combination of the informational structure and the flow of execution. And I think that to develop the algorithm that allows you to think about the problems, you need to understand the connection between the two. So trying to create a tool that allows you to visualize this and to think about, like, when you see a problem, what is the best way to find the solution, like the best sequence of steps that you need to go through your mind. Yeah, and the way that I did this is by appending all the stuff to the list, and then I write. Yeah, so this is the stuff that I used to create. You just use the sys library and then set trace, and then starts tracing the execution, and then you call whatever you want to call, and then it's going to track everything that happens between this endpoint and this endpoint, and it's going to call this function here. Which is this thing here. I'm passing this function as an argument to the thing. So it gets everything from this. Yeah, because everything that happens here goes inside of this function here. And then I get all this information appended to lists, and then I create the data frame based on the lists. So I think I'm gonna copy this one, and I'm gonna paste, and then I'm gonna use another file to just try to, instead of appending to the CSV, just get the information that I think I'm gonna need, and then create the graph directly from the information. That's the thing, just printing here, it doesn't help because there's no way for me to know when it's branching off. That's the thing, so that's why it's better to visualize, to put on this thing here. I think I'm gonna delete everything here and then I'll think about what I will need. Oh, there's also this thing that you can capture different frames, arguments and local variables. This sounds interesting. Oh, and then I did a string to convert the tuples. I did a function to convert the strings into tuples, I think, or the other way around. I'm gonna remove this list. And this sounds interesting as well. I think the graph has to be like, well, there's multiple different graphs that I can do. One of the graphs, I think I should just put the stack frames and then make the stack frames. But the thing is, I would want to know all the I want to know all the information that exists on the stack frame and then connect the stack frames. But then if I do that with network X, then the only way would be to create other nodes, I think. But maybe I can put as a string the information that exists on each one as a label, the variables, and then I put the thing, and then I visualize what I want to happen and what I expect to happen is that if I put the function there, it's just gonna create the tree structure with the frames as nodes connected to each other, and then I want to navigate through that structure and see how the variables change at each step. Maybe I put an ID as well to try to show the order that they are executed. Let me see. What is this function? I'm just converting, just joining, and then returning the string. Yes, I'm converting the tuple into a string. So I think I'm gonna leave it like this. I think I need to go to the other one to see how I was importing. And then I saw. And delete all this stuff. I think I'm gonna put if name equals main here. So that it only runs the file once I call there, only runs the function. Oh, I need to pass this thing here. Oh, but then I don't have the... Or maybe I should just put it as the... But either way, I'm gonna have to pass this stuff to the function. I guess I would just do it like this, and then I'll put the information here, the global bats. So what I need to remember is what each thing is. I think I'm gonna use ChatGPT for this. And then you should look at the documentation. I don't remember which page it is as well. Yeah, ChatGPT is really helpful for this kind of stuff. Even though there's a lot of things that it says that are not correct. Because it allows you to at least start with a very good baseline. And I can just test it out and change whatever doesn't work. And can use it to debug as well. Like the main thing that I'm trying to clarify here is like what kind of stuff exactly do I need, because I remember the biggest problem that I had the previous time that I was doing this is the essence of what I'm trying to get at is to just print the stuff that I was trying to get at last time, was to just print the stuff that is not visible when you look at the source code, because that's the main thing that is hard to understand when you're studying a library, studying the source code, because they're following the execution of the functions, but then there are some gaps that it doesn't, like, you don't know what's happens because it's abstract, so it's not really shown in the code. It's more some stuff that is like variables being passed around and that they're in some place in memory and then they're being changed, but because everything is, it gets really complex and these variables are being passed around, it's very hard to visualize what's going on, and that's where I wanted to get at. Like, how can I get only those things that are not you can't really see on the source code and put them on the visualization, because that would allow you to follow the script and the path of the stack frame and see how the stuff changes. So here I'm trying to think about the same thing, but in a different way, where I just want to get the stuff that is gonna matter, which, so because the way that the Python shows the information and all of the stuff, it gets kind of confusing, and it's not like the way that I want to show it is just the names of the variables here. Like, I want to be able to just see that exactly which variable it is and what the information that the variable has. But the way that it prints there is going to show either some functions or show that, like the dunder method, or shows that it's an object referencing memory at some position, and that's not useful, obviously. So that's the challenge with this kind of stuff. Like, so how can I get to the point where in the visualization I only have the names of the stuff that I'm trying to keep track of and the execution of the stack frames, so that I can just look at the graph and understand what's going on. And then I can modify the function, and it's gonna allow me to become better at thinking about the flow of the recursion, what's gonna happen when you design the code. So I'm just gonna copy this stuff. Maybe I'll do just from the ChatGPT thing here, and then because I have the other one saved on this other file, then I see if there's anything else or change the kind of stuff that I need. Add the current frame node to the network. As a node. Yeah, this way that it is creating is going to create different nodes for the frame. And this is stuff that I was talking about earlier. Which I think it might be better to, but obviously I can change, but it might be better to just put everything inside of a string and make part of the node of the frame, and then connect the frames instead. I think that's better to visualize. So this is recursive function as well. So it's getting the final stack and then going back through with the f back thing. So it does a different way there. Instead of doing like I did here. Okay, I forgot how to move it up. I think it's Alt, yeah, Alt and then arrow key. So here instead, I'm just gonna copy the code here and then I'm gonna run to see what happens with this one. I think you need to call the show method as well at the end. So nuts.show. I'm gonna get from the other script, so I don't have to think about it. And this is gonna put the physics thing on the simulation so you can change the parameters. I think I'll just run this and then see. Oh, I need to copy the other stuff here from there, and then I'm just gonna see what kind of graph it produces. Oh, I need to pass this stuff here. Fuck. I think I don't need to put this result here. The thing is, if I do it like this, is it gonna run everything here? But I think I put this on the if name equals main there, so. That's I wonder if it's gonna create a folder as well. I think it will. But maybe it breaks. No, it didn't create anything. Oh, I have to... No. Let's see. It's just calling the function and then calling this the extract stack. Yeah, but I'm not calling the create frame graph anymore. So don't I have to pass this? Yeah, so this is the parts. So I think I need to call this after I do that thing. So I think, yeah, this creates an object with all the frames before. And then you loop over and then you pass those frames to the function. And then each one is gonna create a graph. Like each frame is gonna be a separate graph with all the frames that frame contained recursively. Also, you need to save it later. Oh, frame graph. Go. I should probably remove the print statements inside of here as well. I don't understand what it's telling me to do here. Let me see if I understand here. So it's gonna create. I'm calling and passing the frames. So inside of here there's a string, which is this stuff here. So maybe I should go to the documentation and just search for this so I understand better, or I can just look at the source code. I think it's F12 here. I'll trace back from the current stack frame. The return value has the same format as for extract db. So that's the thing. So I have to understand what this stuff is going to give me first, because then I'm going to pass this inside of the function, and then I need to handle the different kinds of things that this is going to receive. ChatGPT wasn't expecting a string here. It was just expecting code objects, but then maybe there's something wrong with the response from ChatGPT. But I think I understand the logic. So, and also the other thing that I don't understand is why I create the graph inside of here. If we're gonna create the, it doesn't make a lot of sense to me, because even if you're gonna create, because you need to add the nodes, like if that's the reason, it doesn't make sense, because you're creating a different graph for each one, so it doesn't make a lot of sense. For each frame, let's say. For each object on each frame, I think. No, because the trace contains all the frames. And why I'm passing frame 0 here? Maybe I should print here to see what is going to be the frame first. And then I see like what this is going to receive. But the way that I'm thinking about it now is that this, from this point on, this is going to trace, get all the stacks that happen, all the frames that happen before this part here, which is this code. And I think it doesn't get the functions because there's no execution, it's just the declaration of the functions. Maybe there's a problem with the imports as well. But then it's going to get everything that happened here on the stack frames, and then this is going to be contained inside of this variable. And then I'm looping through each frame and calling the first index of the frame, passing that into this function. And then I combine everything with this function here into this graph. But here I think that I should just add the nodes based on the frames graph instead of the other function. But maybe the reason why is creating a different graph for each one is because the combine function combines all of the graphs that were created into a single one, which is this one. So I think that's what's happening probably. That's why it creates each one here, because each graph is going to be from its own frame. And then here, so first you get the function name based on this frame.f code. So it's expecting a frame and I'm receiving a string. And that's the problem that I'm getting here. Because this is going to be a string and it's supposed to be a frame. So I need to understand why. And then you make that into a string and use the built-in ID function, which I don't know what it does exactly. Obviously, it's something related to the identification, but I don't know exactly how it works. And then you add that as a node to the network. And then you loop through the global and local variables, and then you add that as nodes to the current frame. So I think it's pretty easy to understand. So just have to print there and then see what I'm getting out of the frame and understand the function as well. But if it works the way that I'm thinking, is exactly what I want to think, which is just the global and local variables and the frame name. So it's creating a graph of each But the only difference is it might be better to put this as a string and connect it to just create one node for each frame, and then just keep track of the connection between frames and make everything as part of the label for each frame. So at the end I have the tree structure. And this part also you need to understand. I think this one gets the parent frame, let's say, the one that happened before the current one. Yeah, so it goes back from this one to the other ones that happened before. We're calling recursively until it gets to the point where there's no parent, and then returns the graph. So each one creates its own graph and then combines everything into this one, and then returns, and then combines everything here as well. So I think I understand what happens here. I'm gonna comment the other stuff out, and then I'm just gonna run to print and see what's going on here. And then I'm gonna ask to explain what it does. The route trace back from the current stack frame. Let me think. Just a frame summary. One is the 0. Return value has same format as struct db. The optional f and limit arguments have the same meaning as for print star. Let's see what a frame summary is. I think I understand much better now this time, like, even though I don't know how to use it yet, but like it's a lot easier for me to understand now everything that is going on by reading this stuff than it was before. Like before, the first time that I saw this, I had no idea how everything was. And I think what helped me the most was the Ben Eater videos. They were very extremely good. But obviously there's still a lot to learn, so. But I think I have a much better idea of how everything works. And I also want to study more how like the Python interpreter works, how it creates the abstract syntax tree and how it defines everything. How like, what are the design? This is the stuff that is, like, I understand it much better now, but it is not clear in my mind what are the trade-offs for each language and the way that they decided to do each thing. Which is how like, what are the decisions that were made to determine the way that the memory is going to be stored and the way that the stack is going to work, the heap and things like that, and the way that the Python is going to communicate with the operational system, with the built-in libraries, and the import system as well. How is that decided, and why was decided the way that it is? And the whole thing about threads as well, like what are the decisions when it comes to threads. I think I remember studying the stuff about the GIL, global interpreter lock, the Python has, and that makes Python slower as well. But then it's easier or something like that. That I think it locks the thread, but I don't remember really well. I'll have to study more about that. Yeah, so I don't understand, because this is giving me the name of the file. It's probably as a string because of the error that I got there. And it seems like it only gives me one stack, one frame. So I don't understand how this is gonna... Maybe the ChatGPT thing is wrong. Maybe if I want to do it this way, I have to put this inside of the function and then call. Then it gets more complicated, I think. Extract stack function is a method provided by the Python traceback module, which allows you to extract the current stack frame information at the point where the function is called. When you call the extract stack function, it generates a traceback object that contains a list of stack frames, each representing a function call in the call stack. The frames are listed in reverse order, so the last frame in the list represents the current executing function, and the frames before that represent the calling function in the call stack. Let me see how he told me to use this again. Yeah, just calls. Maybe I need to make this the thing equal to a variable. That's the difference there. Problem is that I have to loop over the actions. I think I can make equal to 1 first, and then I'll... Yeah, I'm gonna do it exactly like it is there, to see if it changes anything. So just comment this out for now. Let's see if it changes anything. No, it still receive the same stuff. And if I do like this, it's probably gonna complain that the string object, whatever, doesn't have the frame thing. Yeah, because I'm receiving the name of the file. Let's put here and see if it changes anything. Probably not gonna change anything. So maybe I need to put this inside of the function, inside of a function and then call. But I don't see how that would change because that would just change the scope. But I'm pretty much doing the same thing, I think. Because I am calling the other function before. And then calling the traceback extract stack thing. So it should show me the frame from the other function, which should contain all the other frames as well. Maybe I should print the trace thing, but it's only gonna be the thing. And 121. I'm sorry. Yeah, it's only showing me. Maybe let me. Yeah, but then if I do remove, it's not gonna. Maybe this receives arguments. Yeah, it should pass as an argument, I think. And also try this other stuff here. I can do the same thing, but I think it's not gonna work. Like you can put the trace on these other methods and call in the same way that the thing here is calling, but it's not gonna work, I think. So why is it showing the name of the file if I'm calling the function and not showing anything else? So yeah, it's not gonna change anything if I don't make it like this though. I think the problem is the way that ChatGPT gave me the information, because the point of the function seems to be to give you the last line and file and line of that was executed, and that is the frame. So it doesn't make sense to pass this into the other function to get the object, or to, because it's not going to be a code object, it's going to be a string. So it doesn't make sense to pass inside of this function here, it's not really a frame. I guess I could just look at the source code. Yeah, frame summary. So it does return this class here. So I can just look at the class and then see the methods, because I'm passing this. I can also print the type, but if I pass this frame there, let's see, I didn't test this. Instead of passing 0, I just pass the. But maybe now is different. Yeah, it doesn't work. Frame summary has no object fcall. But I can see what methods I have here, and then from the methods I have on the class, I can see what kind of information I can get. Yeah, but so this is what I think is happening. Like, here it gets the last frame summary that happened, and then which returns this class, which is the stack summary. And then from the stack summary, I can see if there's a method that is going to allow me to get the other stacks. If there isn't, then I can go the other route, which is just use the other method that I was using of this csat trace, and then call the function inside. And then I can just combine what I did before with the stuff that ChatGPT gave me, which is just create the graphs, separate graphs, and then connect the graphs at the end here. But after the thing is created. And then I have to change the name here, true. But I'm not sure if this way is gonna... it's probably the same thing actually. Because, yeah, the point of the other one, yeah, I think it's gonna work if I do it like this. But I wanna understand this way first, because it might be better. And so it looks like it doesn't have anything that seems useful here. Because the problem is if I only get the last frame, then it's not useful at all. And if I can't get any code objects from the frames as well, it's not useful, I think. Maybe I can call this extract there and see what happens. And I have to see what I need to pass. And it's a class method. I don't remember really well. I think class methods, like they are called when you initialize the class, but I don't remember how it works really well. And the first argument is the class itself, I think. Something like that. Yeah, that's the thing that I was thinking about. I don't understand what kind of generator I need to pass there. And it doesn't return a tuple, I think. Let me think. I think ChatGPT, the answer is wrong, probably. I think this way, to be honest, doesn't seem very good, so I think the other way is probably better, the one that I was doing before, with the set trace. Because this way you're getting the name of the file and then creating the frame from the name. But the other way, it allows you to create the trace directly, I think. And you need to review how class methods work, but I think it's a method that allows you to initialize the class later or something like that. You pass the instance of the class as an argument. I'll close this other. I shared among all objects. The parameter is always a class itself. So you don't need to pass? No, you... I don't like this explanation that much. What I'm gonna do before I stop is try to do this method that I did, but then create this stuff here later. But the thing is, because if I do it this way, I think it's different, the logic. Because as is executing this, is gonna pass everything that happens inside of this function here. So I think I would have to create the whole graph through this function. So this doesn't matter at the end. So let me try like this first and see what happens. And then I would need to do this thing here inside of the function at the end. I'm not sure if it's gonna work, especially with this recursive call here. I probably have to change this. But I'm curious to see what's gonna happen if I do it like this. Maybe it's better to put this stuff here at the end. Yeah, because it's gonna pass everything through this. But I think that this maybe it works. But then I have to create the... And the problem is the recursive call. I think the graph has to be a global object. So it doesn't create a new one. Unless I combine in the end. Oh, it combines here, so maybe that's fine. But it feels like it would be better to just create a global object and then just create one graph. So here you guess the name of the current function, and then guess the global and local variables of the current function. Adds the edges and the nodes, and then calls recursively. And then as this runs, it traces everything that happens. Let me try to run like this, see what happens. And I need to study more all of this stuff about the information that you can get and how to get the information, the best way to get the information. And I think I'm gonna do this for the next few streams until I have at least some visualization. I wanna go really hard on understanding recursion until I get it and until it becomes intuitive and automatic to think about. Because that way, I can solve that part, and then it's gonna be a lot easier to debug the other code if it's wrong, or to think about other ways to create the trees. Is one position argument the tree were given? Because I'm passing the rain, but it's calling it here. Let me think about this. So what I guess is happening is that this function only has one argument, but then this function has three. And then I don't understand the relationship between the arguments. That's the problem. Maybe I have to go here and then I always forget that is F12. And then see, I think that there was something, if I remember, that you can pass. Maybe you pass as other arguments here. Maybe I will use ChatGPT. Because I don't think you have to, like, calling doesn't make sense to me, I think. Calling the function here with the three arguments here doesn't make a lot of sense. But I think there's a way to pass, maybe as arguments here, the arguments that this function uses, or something like that. But I also have to understand better how it works, so I know that I'm receiving the correct thing here as the argument of this function. Maybe Python documentation. Inbuilt function in Python which returns a class method for a given function. Function that needs to be converted into a class method. Static methods know nothing about the class state. They are utility type methods that take some parameters and work upon the parameters. Class must have class as a parameter. It's not really. I don't like these explanations that much. I will study this stuff later. I don't like these explanations that much. Maybe if I just put frame. But it's saying that it accepts only one. Oh, maybe that's why. Because it requires to have the events and the art here. Maybe that's the problem. Even though I'm not gonna use them. Oh, and this is the... here. So I think like this, the way that I can do it probably... But I'm not really sure. Like create a graph globally and then just create one graph and then append each time. Maybe that works instead of calling recursively here. Yeah, I think that the recursion doesn't make a lot of sense if I do it like this, the way that I'm doing now. Because it's a different thing. I love it. Let's try like this. So it's not creating a graph. I think I'm gonna stop here. I'm gonna study this stuff off stream. The next time I'm gonna continue to do this stuff here. I'm probably gonna continue to do this until I have the visualization. Yeah, and then once I have that, then I'll go back to... I'm probably gonna work on the poker tool as well, off stream. But on stream I do this stuff until I have the visualization, and then I'll go back to the poker tool once I have that. So, probably gonna come back tomorrow. Yeah, see you.